how to import data into a data lake. And to my help here today, I got Barry, my good friend and colleague, who's done this a lot of. At the moment, I think we are running it in a couple of data lakes, and currently we are trying to implement 5 different data lakes. So this is a good tool for us. So Barry, take it away.
Hey, and welcome everybody. My name is Barry Westerlund. I'm one of the architects and system developers for Hadoop environments and data lake here in Middletown. And today I'd like to take the opportunity to talk about a tool called DBImport. Now, DBImport is, well, if you look at it another way, what's the data ingestion problem? We all have to, everybody that works with some kind of data lake have the problem with ingesting the data into the data lake. So you have the problem with that the large tables, they take forever and ever to ingest because it's so much data to get in there. You also have the problem with incremental data. You need to handle that in some way. It's not as easy as it sounds. I wish it was. And you also have the problem with that the source system actually changes all the time. You do set it up once and it's never the same the next day you come into office. This is a really common one. I've seen this a number of times. I've done it myself. So you get a Hadoop environment, you get a data lake up and running. You do some first tests with Scoop, you download some test systems, maybe even production systems, and it works great. Customer is happy. But then they request more and more data, more and more tables, more and more systems. And for every one of those systems, you have to do manual work. Takes a lot of time. Now, someone comes to think about, let's script this up. Let's put it into bash scripts, maybe put it into cron so we can have schedule it in different times. That's where you split it up. I've done this myself so many times. Then you get the problem that the system changes. The source system changes. Now, they add tables, they remove tables, they add columns, they change the columns, they change the meaning of the column. And suddenly you have a very heavy work-intensive thing you need to maintain every day at the office to maintain all these systems. So what you really want is you want a system that have support for all common sources out there, at least the ones that we have here. You want auto discovery of whatever is out there on the source system. You do not want to be able to have to do this manually because it's a lot of work. You want to handle the full imports, the incremental imports. You also want to handle exports, even though we don't maybe want to, but system requires us to export data from the data lake as well. You want CDC functionality, so that you can actually only get the changes from the source systems sent to the data lake. As soon as something changes on the source system, you want that to be handled automatically. You do not want manual intervention in order to get a successful load of the data. And that goes for column descriptions, table descriptions, the keys, primary keys, foreign keys, all of that things should come automatically from the source systems. If there are a change, you also want audit of that data, so you know what has been changed. Because otherwise, the end user comes to you, this program worked yesterday, why doesn't it work today? And this data was changed, and it should be changed, but we need to know about it. You want to be able to parallelize it, because it's a lot of data. You cannot handle that like running a command to do it. And you also want full logging of everything, so you actually know what's been doing. So that's why we have a tool called DBImport. Now, DBImport is a tool that handles import and export to Hive and HDFS from different databases. Also some non-SQL databases, as Mongo is also handling that. The tool comes from basically the problems I talked about a couple of slides ago, because I've been there so many times, where you need to ingest the data. So the experience I've gathered over the years has ended up in writing the tool called DBImport. The tool is right now deployed in production in different systems here in Sweden. The largest ones are importing, and these numbers are from like November or something. So then they import roughly 15,000 tables per day from 200, I think it's 250 plus systems today. And that's not all kind of brands. I think they have Oracle, Microsoft, MySQL, Mongo, MariaDB, probably some more that I can't even think about. They have a lot of them. Licensed by normal Apache licenses, full open source, everything is out there. It's available on Git. The link is at the end of the presentation. So the key functionality of DBImport is that we have support for the most major systems out there when it comes to source data. And this is for both importing and exporting, no difference. It uses Scoop or Spark in the background, depending on what your flavor is. It's up to you. Choose whatever you want to. Everybody says, use Spark, it's so much faster. I beg to differ. It's not always faster. Some cases it is, some cases Scoop is a lot faster. So choose what you want. It has auto-discover of everything. So regardless of what kind of changes is out there, it will discover those changes. If they add a new table, it will discover them, find them, and import them automatically. It will create all the things in the Hadoop environment for you. So if you have decided that system A will be imported into Hive database A, all the tables in there will be created for you. You don't have to do that manually. And you don't have to maintain it either. So it also has support for both full and incremental import and export. It has support for CDC, right now only for Oracle, with the Oracle Flashback Query functionality. So there is CDC functionality within the tool. Some customers have multiple Hadoop systems, maybe spread over different continents or even just two different systems because they can. Maybe it's they're in the middle of an upgrade or something like that. So the system can also handle that scenario where you only hit the source system once and then the data is spread among different data lakes. Because just because you have 6 different Hadoop environments, you don't want to hit the source system 6 times because they're going to get cranky if we do that. It have automatic retries, so if something goes wrong during an import, it happens, then it will retry and continue from the part it's left off, so it doesn't have to do the entire thing from the beginning. It handles all the column definition changes, so if you have a varchar 4 that's been changed to a varchar 8, it will be done. Column description, so the changes of column descriptions and table description, really good for the metadata, because you need to know what the data is. If that's updated on the source system, it's going to be updated in Hive as well. Primary foreign keys.
Barry, are you going to talk a little bit on performance impact on source systems?
No, didn't think about that.
Have you seen any impact on the source systems?
I mean, we're still talking Scoop and Spark. So if you decide to run with 128 parallel sessions against one table and read all tables at the same time, yes, you will see an impact. If you run one session against one table at a time, no, you will not see an impact. So try to go as high as you can without the end user being cranky. That's a good point. So I will try to speed it up a bit, but what you can do with the CDC functionality, that you can use the merge functionality within Hive to actually get that data in, to make sure that you only load the changes from the source systems. So that's fully supported within DBImport as well. You have the audit functionality. This is a really powerful one actually. It will detect all the changes in a table from one day to another, regardless if the system itself actually logs that data. So you can, in the Hadoop environment, create new data based on what the source system, the differences between the different times you read the data from the source systems. So you create a full audit in the Hadoop environments. Usually that information is not available in the source system. So in this case, you can use it to create new value inside the data lake on data that you don't even have access to in the source systems. So you keep track of all the changes, basically. Really useful in order to find out how a certain value ended up where it ended up, because you can track how it was changed over time.
Yeah, so you create your own data within
Yes, you can create your own data with the help of the DBImport tool.
Okay.
And this is also something that is done automatically. You don't have to do it. The only thing you do is that I want audit on this table. and the tool will create the tables in Hive and start to do the audits for you. We also have a very tight integration together with Apache Airflow. If you haven't seen Airflow, it's a scheduling tool basically, where you can define dependencies between different tasks and jobs. And DBImport have a very tight integration together with that tool, which makes it very simple to schedule jobs in parallel to gain the performance of running huge systems at the same time. You have full logging and statistics of everything happening inside the tool. So if you do an import and you want to find out how long time did it take to run the scoop part and how long did it take to run the merge part, all that statistics is logged. And we also have an integration together with Atlas. So all the lineage, which means that how is data flowing through your system, together with the metadata on how does a source system actually look like, what kind of tables are there, columns are there, stuff like that, invaluable for people using metadatas. That is also automatically imported with the help of DBImport. So you get that updated in Atlas. Ease of use is kind of important. So how do you actually do it? First of all, you create a connection to the source system. You need to specify which server it is, which port there is, username and password, which database to connect to. That's kind of a no-brainer. You have that information. Then you run a discovery command saying, I want to import everything from that connection into this Hive database. One command. Once that is done, you create a configuration for a DAG saying, I want to import everything from that database. You generate it to Airflow, which means that basically the information will now be available inside Airflow. So in Airflow, you now press the play, start button. And from that point forward, every time you run that, the data will be imported, all the metadata will be updated. So if something changes in the source systems, they added a column, stuff like that, that will be reflected inside Hive as well. So you don't have to do anything else. So the only thing you need to do from this point forward is to schedule this job once a day, once an hour, once a month, and the data in the data lake will be updated, and you have full logging and everything. It's as simple as that. Then you can tweak it, of course. I want to run with fewer parallel session in order to not hit the source system as much, or I want to run with Spark instead of Scoop, or I want to run incremental, so that's up to you. But this is just that. Questions? None. Everything is crystal clear. It's so good. I love that.
It's like it's going in to my brain. Very interesting. So what you're basically doing is it's a fantastic productivity for people, and obviously it's a much more reliable way to import the data.
You remove all the work of having to work with daily changes and following up of work of changes of the systems.
What has been your initial, use case, business area?
Basically, the customer that started with it needed a data lake where all the data in the company, global, was available in one place where the data scientists could do their thesis and their work, basically. It was too much work for them to connect to different source systems to find the data in there. And that just continued on, so they are now running with like 250 databases. 15,000 plus tables per day imported in terabyte scale every day with the help of this tool.
How often do you run the tool against time-critical systems? Do you do it every second, or?
That depends on what we allowed and what the requirements are. Let's say it's a BI application and they only want updated figures for the morning when they arrive, then we run it once. But maybe it's close to a book ending or something like that, then we need to run it every hour or every 20 minutes or something like that. It's up to the source systems. What they and the user, what they require, obviously. I'm gonna skip a number of pages. There it was. You all noticed it, right? Yeah. Any questions?
Perfect. Wait, the third table though.
Yeah.
Very good. Yeah.
I want to see the table.
It was a lot of examples of what the different imports are doing, but I was actually thinking of skipping over that part. So the presentation is there. You can take part of it and use that or whatever. I'd like to talk about how we handle source table changes, because this is actually a big deal. This happens all the time, every day. So this is about the source system actually changing. Maybe they are running an upgrade, so they change the tables, or if it is a self-developed systems, the DBAs are changing stuff in the database. Create new indexes, change the description of a column, so you get better metadata, stuff like that. And to make sure that that is available in the data lake is a lot of work. So what DBImport is doing for you is handling all those changes. So renaming columns, common case if it's a self-developed systems, that's handled automatically. So if the column was called A and now B, it's going to be called B in the morning when you arrived in the office, in Hive. The add a column, that's also going to be handled, so that's going to be available in Hive as well. The delete column, also handled. They change the type, the most common one to be honest. They changed the type from varchar 12 to varchar 14 because some character didn't just fit in there. And stupidly you miss this in the Hadoop environment, and the import starts running and they still continues to run. And then the end user calls up the data lake team and wonders, why am I missing the two last digits here? They are very important, and you don't have a clue. This to make sure that you do have those changes in the data lake as well. The comments on both columns and tables are handled automatically. Now why is that so important? Because that is usually where the DBAs or the designers of the system actually wrote down what the meaning of the values in this column. So maybe it's a very simple one is 1 means true, 0 means false. Usually you can make that out yourself, but maybe sometimes it means 2 means true and 0 means maybe. That's harder. It do happen, so you need to have that metadata.
If you have a name change from A to B on a column, and you would like to, that is certainly something that happens at a certain point in time. If you ask for data that's previous to this time, will it be the new value or the old value?
Depends on how you do the import. Mm-hmm. If it is a full import, that means full import basically means truncate what you have in Hive and read everything in again. Well, then obviously you get the new values. If it is an incremental value, then you already have that one. So then you have the old value in there, because the value itself doesn't change. It's only the definition of the table that changes. Value should be the same. There are certain exceptions of that one as well, obviously, but that's usually the case. We talked about keys as well. If those changes is also handled automatically, so that's always in there. Now, you also want to know about that. You know, to know about what's actually been changed. So there is an audit functionality within DBImport, so that you can actually see that that column in that table in that database was changed from a varchar 8 to a varchar 12. You have the previous values, you have the new values. So everything is logged to make sure that you don't miss anything.
Can you turn it into a report?
Yes, absolutely. It's inside the database. So the data is stored in a table. So you just read that one out, publish it on the web. You do it, but everything is in your table. I'd like to talk about Airflow a bit. Now Airflow is a open source tool for scheduling and workflow management systems. You basically define a job which have a number of tasks, and the task itself have dependencies between them. No rocket science there. You also get a lot of statistics about how long time did it take to run, stuff like that basically. Really great tool. I haven't checked it, so please do. It's really good. What DBImport is doing is everything within Airflow. Airflow is written in Python. DBImport is also written in Python. So all the jobs in Airflow are handled inside Python files basically. So a DAG is a Python file. What DBImport is doing is generating those Python files for you with the right syntax and right dependency, everything. So once you create a job, generate the file, it will end up in Airflow, and you can view the job there. And this is typical. This is actually my job that I used before to test out changes when I develop stuff. So this is my Airflow job. So I have a start, I have all the tasks in there, and I have an end of it, basically. What you see is there as well is you can very simply configure how these tags or how these jobs are generated. As you see here, there are different. They see a number of those as with the name import at the end, and a number with the ETL at the end. Now there's a difference. Inside DBImport, there are 3 different stages. The first one is an import stage. Second one is a copy stage. We'll talk about that one later. And the third one is an ETL stage. The import stage is actually one. Think of it like that's the one that connects to the source systems, reads the metadata, and reads the data and store it on HDFS. That's what the import stage is doing. The ETL stage is taking the data from HDFS, put it into Hive. That's the difference. Sometimes you want to separate those due to maybe how many parallel sessions you can run against the source systems, and with the help of you just change the configuration, you can make sure that the data is first loaded into HDFS, verified for all the tables in the source system before you change the data in Hive. So you don't update 4 tables, but not the 5th, and then you have like foreign keys that doesn't match anymore because the values are not there, stuff like that. So you can make sure that that happens. Just a simple configuration in the DBImport, that's going to happen. You can also add other jobs and dependencies within this job. So a very common one is that you can, let's say that you import stuff into the data lake, and from that data lake you want some users to start using it. Maybe a data warehouse can update their data fact tables and dimensions. So at the end you could, for example, connect to a source system and run a store procedure. Maybe send an email to someone saying that the import is completed. Maybe connect and start up a VPN tunnel before you connect to the remote system and fetch the data, then stop the VPN tunnel at the end. Stuff like that can be done. That's also configurable within DBImport. Any questions about Airflow?
Is Airflow a part of the Cloudera package?
No. It's an open source one, so works great. Will most likely be included in the Cloudera package, but haven't 100% decided on that one yet. But it looks like they will. That's going to be really good. Now, Atlas integration. Atlas is the metadata system that we have in the Hadoop environment. Data governance systems, all the descriptions of all the data is in there. Within Atlas, from a certain version, I think it's version 2.0, there are a specific data type called RDMS underscore and something, RDBMS database, RDBMS table instance, stuff like that. What DBImport is doing is using those values, those types, and make sure that those are updated with the correct information, like what the source system looks like. Excuse me. Because DBImport connects to the source systems. They know exactly what the table looks like, they know which database it is, they know what columns are there, which descriptions, foreign keys, relationships, everything. So it uses that information and updates Atlas with it. So with the help of DBImport, you have a fully updated and automatically updated metadata repository of all your databases out there, not only the Hadoop environment. So there are 2 different ways to get the data in there. I assume that you configure Atlas for this, obviously. As soon as you run an import and an export, that data is going to be imported into Atlas. That's done automatically. Then you're just going to see a single row when you run saying Atlas is updated. That's it, and the data is there. There is also a server for DBImport running. And that one can connect to the source systems, discover everything that's there, and put it into Atlas. So regardless if you import data from that source system or not, as long as it's configured, DBImport will make sure that you have the metadata for it. So just because you're not importing it, it could be very valuable for the end users to know that the data is there. What DBImport is doing is these the ones out here, those are standard types in Atlas. This is how you see different entities, and this is how you see the lineage. You know where the data has been flowing. What DBImport is doing is adding a separate, its own data type, basically, into Atlas to make sure that the RDBMS, in this case is an Oracle system, gets connected with the DBImport process. And if you go into the details here, you can see who ran it, at what time, which command, stuff like that. Ends up in HDFS, there's a command to create an external table, and then it ends up in a Hive table at the end. This is also done automatically. The only thing you need to do is saying Atlas is at that address, and that's the user I'm going to use when I talk to Atlas, because it needs permission to do it. Then it's handled automatically in the background. So it's a very simple way to get a metadata system up and running, and it's going to be kept updated as well.
On Atlas there, if you need to set different access parameters on the data, if you are a government entity, for instance, and some data is used for one purpose, another set of data is used for another purpose, and you need to block out the different data, could you do that automatically in this tool, or?
You can do it with help of Atlas, but that's not really kind of outside the scope of DBImport as a tool a bit. You can do it with the help of Atlas together with Ranger. Very possible to do that. And you also get like the lineage will make sure that the tags you set on this system will be following down through the chain in the lineage one. So that's going to end up on the Hive table as well. But it's not part of DBImport.
You mean like encrypting a column or something like that?
Yeah, you can say if you have social security number in one column, if you are a government agent and you're allowed to see that, but if you're just a simple administrator, you're probably not allowed to see that.
It's very simple to do. What you do, you use the functionality within Atlas called tags. So you put a certain tag on an object. An object can be a database, a table, a column, anything. And so you put that, let's say, on a column. And then inside Ranger, you make sure that data that have this tag will be masked. And then you can specify how will that be masked. For example, the Swedish social security number maybe should just show the first 6 digits. Then you do that, and the rest will just be X. So you see a portion of the data. Maybe you just want to null the value or put a hash key there, something like that. So that functionality we built into Ranger. Very simple to use. It's a no-brainer. We do it all day long.
Encryption,
so that's doable, absolutely.
And also for things like Sarbanes-Oxley and the financial.
Yes, absolutely. And different user groups should see certain points. For some users should maybe you should see something,
etc. So that's a big.
So some function can be handled for some person.
Yeah.
Or department, or maybe use some passport.
Exactly. So, and you can also combine that with the row level security. This is way outside DBImport now, but so in Ranger you can actually handle that. So both the column level and the row level can be handled. So maybe you can only see these columns for the department you're working in, even though the whole company is in the same table. For example, the HR systems is a typical use case for that one.
Transport Steelson, a customer of yours. They should be.
Yeah, they should be.
I was saying, if you get
So yes, that's doable. We do it every day. All right, some of us have not only one data lake. Those were the glory days when we only had one. Today we have multiple ones. And if we're lucky, they're actually in the same data center, but they're usually not. There is one on Amazon, and one on Azure, and one on some other cloud vendor somewhere, and some on the private cloud, and some on the bare bone metal in the data center, one in Asia. You need to handle that. And you do not want to hit the source systems from all those data lakes, because those source system owners are going to get really cranky when you hit them with X number of parallel sessions for X number of data lakes. So what DBImport is doing for you is making sure that one system, the master, import the data from the source systems. Then once that's in HDFS on that data lake, it will spread the data to the other data lake without inflicting load on the source systems. This can be done in two different ways. One is a synchronous way, basically means you will sync the data when you do the import. The other one is an asynchronous way where you're basically going to say, I'm done with the import. I'm going to send an API call to the server, the DBImport server, and the DBImport server will in the background make sure that the data is synchronized so the main cluster still can continue with the import. Depends on your requirements. The data will still be synced between the clusters.
If you have a large data set, you will probably do some kind of asynchronous import. Have you seen any differences there? How big? What is a big data set?
How long is the road?
Yeah.
It's kind of impossible to answer. It usually depends on access, to be honest. If it is asynchronous way, it's going to be the DBImport server that is doing the copy of data, which means that the DBImport server, the user running that one, needs to have permissions to the databases in both the source system and the target systems. Some usually it can, because that's the most common one. But there are certain cases, HR systems is one of them. Front-end development systems, stuff that can affect the stock market, stuff like that. You don't want like the entire data lake team to have access to. So those are very restricted, and then you need to run with synchronous copy to make sure that it's that user that is actually copying the data. So it's basically, it goes down to the permission.
Yeah, it's case by case. Isn't
It's really case by case. So we are running both, and both are running fine. So that's what it. Any questions?
Oh yeah, interesting. So, will we have a chance to look at your slides? Will you?
I will. My plan was to upload them to SlideShare, and we can
right.
send you the links, or we can just send it as a PDF, so you can send
Yeah,
it
but
as well.
We will distribute it through the Meetup app, so you will get the and
Really?
you'll also get the link to the GitHub where you can download
So
this.
before you
Yeah.
go further, if there is someone like to contribute, please let me know. I'm the lead developer for the project. Basically, I've been writing roughly 100% of the code.
Okay. Yeah. Thanks very much. Very interesting. Very
So the links are here. So the Git is here. The documentation is also there. Everything is in there. And you have my email. So just send me a question if you want anything.
Yeah. I mean, it's really interesting, and like as a brand new to this, I would say a few more diagrams maybe as well. But very interesting, and I'm sold. but it's as I said, I haven't worked with this sort of problem for a few years, but I guess it's quite a interesting market.
Yeah, I mean, the company that had the 15,000 tables, I think it's more like 16, 17,000 tables now in different clusters as well. So they have a multi-cluster setup. They have, I think it's 3-4 people maintaining those imports. It's a huge workload for that amount of few people they are, and they managed to do it. It's really impressive. And you sitting there in the middle with the bear is actually one of those persons. So. All right. Thank you so much for showing up.
Yeah.